right, so find all the rational zeros of the polynomial. What they're asking you to do when they say that, they're saying use your synthetic division process with your P over Q choices to go ahead and factor this thing. Okay, and to be honest with you, I think probably finding this first will lead you to the zeros. And I just depending, I guess, how you view it. I think of trying to develop the P of X first, and then that helps me decide the zeros. I guess as you're doing the synthetic division, you might come up with some of these zeros before you come up with the polynomial, but these two things are directly related. Remember, we want to find our p-values, and the p-values are the factors of that. Okay, so that's going to be plus or minus 1, 2, or 4. Okay, and then we're going to find our q-values, and our q-values are the factors of 3. So plus or minus 1 and plus or minus 3. So then when we write our list of P over Q's, okay, P over Q, so I'll take this 1 and write it over both of these Q's. So plus or minus 1 over 1 and plus or minus 1 over 3. Then I'll take the next P value of 2 and write it over both those Q's. So I get plus or minus 2 over 1 and plus or minus 2 over 3. Then I'll take the last one, the 4, and write that over my Q's. So plus or minus 4 over 1 and plus or minus 4 over 3. A lot of times when we do this, we get some redundancy in our quantities, and here we don't. So we can't kick anything out. Just because I'm running out of room, let me cut this information out, and we'll go to this. All right, so the next thing we're going to do, and you've got some choices. My suggestion to you is probably to graph this thing. 3x cubed, 11x squared, 8, and then negative 4, right? Make sure when you do synthetic division, you have all the, even if there's any zeros, any powers up here that are skipped, plug in those placeholders for that term. But when I said graph it, it'd be a good idea to go to Y1 on my calculator, or if I use GeoGebra or Desmos or whatever, get a visual of this thing, and it helps you then maybe choose which one of these might be the best to look at. Okay, I'm going to kind of look through it and do a couple of these to kind of see, if we didn't use our calculator, kind of show you what we're looking for algebraically. If I use my calculator and I find a 0, then I'm always going to get kind of a particular quotient line here that looks very similar to any other quotient line that I ever write. But if I choose one that's not a 0, and obviously we see the answers here, so I'm going to choose 1 up here. So choose 1, and I bring my 3 down, and then multiply, bring my 3 down, or up, add together, I get 14, multiply that, put the 14 here. That gives me, 22. Multiply the 1 by the 22. It's 22 there. And now I get a remainder of 18, right? Okay. Now, what's nice about this, if we remember what the upper and lower bounds told us, they said if you choose a positive number up here, and you get a result in which all of these things down here are positive, okay? And they could actually be positive or 0, then that tells you that this number of 1 is an upper bound. Okay, it's an upper bound, which means that all of the other values that are greater than 1 will not work. Okay, so what that tells me here is I can go through and I can say, okay, numbers that are greater than 1. Well, I know 1 itself is not going to work. And evidently neither is my eraser. Ah, good call. That's not even written there. Positive 1's not going to work because that was what we chose. But positive 2 is not going to work anymore. Positive 4, I don't have to try. In positive 4/3, I don't have to try. And that just simplifies our list of P over Q's that we have to test. Okay. The next thing maybe you do is try negative 1. Okay. Starting all over again from the beginning with the original polynomial coefficients. Try negative 1. Bring my 3 down, multiply, gives me negative 3, 8, negative 8, so there's a 0, and now it gives me 0 and negative 4. Okay? Now that final line, because that negative 4 is not a 0, then negative 1 is not a 0. But looking at that final line, I'm looking for two relations or two patterns that tell me something about the negative 1. I'm looking for either alternating quotient line in regards to pluses and minuses, and we don't have that, or I'm looking for all positive quotient line, and we don't have that. Okay, and the I want to look at alternating specifically here because we chose a negative number to divide by. Okay, and that's the upper and lower bound theorem. So the only thing that synthetic division tells me is that negative 1 doesn't work, and ultimately I can't kick out any other values. Okay, so then I try another value. Okay, now I'm going to try, because maybe I graph this thing, I'm going to try negative 2. Okay, and if I try negative 2, I'm going to bring my 3 down. Multiply gives me negative 6. Or add gives me 5. Negative 10. Negative 2. Positive 4. And there's my 0, right? Okay. So I know x minus 2. X minus 2 is a factor. Okay. Or sorry, it's x plus 2. It's x minus what you have in the box. So minus a negative becomes positive. So that's a factor. But this was x cubed, right? And this is now x squared, correct? Okay. So at this stage, you've got some options. Okay. In this particular problem, maybe I graphed it and I looked at negative 2. And in the graph at negative 2, you would see that you have tangency to the x-axis. You know visually that that's a multiplicity of an even amount, right? Okay, so it's either a multiplicity of 2 or 4. So you know, if you've used the graph, that negative 2 is going to work again, right? Okay, so we can go through and we can actually do this with negative 2 again. I'm going to start here with negative 2 in my synthetic division. Bring my 3 down. Multiply gives me negative 6. Bring that negative 1 down. Multiply gives me 2. And there's my 0 again, right? So x plus 2 is another factor. So that's multiplicity of 2. Okay? I'll show you an alternative way that you could have gotten that here in a moment. Okay? Usually people that don't look at the graph would probably have done something maybe a little bit different than that division. But now once I do that division, this was x squared. We've broken it down now by another linear factor divided by x again. So x squared divided by x gives me x, right? So this final line in this quotient is 3x minus 1. Okay, well that's a linear term, right? Or a linear factor. Okay, so 3x minus 1 is another factor. So when I want to write P of x, it's x plus 2 times x plus 2 times 3x minus 1. Okay? Or you got some options here. Maybe you want to write this as P of x is equal to x plus 2 squared times 3x minus 1, right? That says the same thing. Or some people like to do this. They like this number right here to be a 1. They like every single one of their linear factors to have an x value or an x coefficient of 1. So if I factor that 3 out, I could do this. I could go 3 x plus 2 squared. And now dividing that 3 out of there would give me 1x. Dividing out of there gives me negative 1/3. And the reason people like to do that is because now you can see right there, that's a 0 of negative 2 with a multiplicity of 2. And that's a 0 of 1/3. Okay? Still something you could have found with 3x minus 1 as being your factor, but regardless, that's kind of maybe how you would do that problem. And WebAssign will accept all those options. Okay? On a test or a quiz, I'll accept anything unless there's specific directions that kind of change what you would do here. Okay? But either way would be fine. Now what I want you guys to realize is at the stage that we did, I went one more step with this negative 2 and found that linear term then. Some people will stop here. Probably not knowing that my graph was tangent at negative 2. But they stop here because if I have 3x squared plus 5x minus 2, do you have alternative ways of factoring that? Yeah, okay. I'm going to use the a times c method. So I multiply 3 and negative 2. That's going to give me negative 1 and positive 6 will multiply together to give me negative 6 and add to give me that 5, right? So I'm going to rewrite this as 3x squared plus 6x minus 1x minus 2. So rewriting the black statement by taking that 5x and rewriting it as a sum of those two numbers. And you can flip-flop those. It doesn't matter the order. Now I'm going to group things. So I'll group the first two, and I will group the last two. When you group the last two, it's a good idea to make sure you group the sign here with the last two, especially if it's negative. Okay, come out of the first two. Yep. So that gives me, what, x plus 2? What come out of the back two? Negative 1. And that leaves me with x plus 2. So then you see the 3x minus 1 show up, and you see that additional x plus 2 show up from that factor, or from that quadratic factor. Does that make sense? Okay. So when we break this down, when we first do the division by negative 2, and we find that x plus 2 is a factor, x plus 2 is a linear factor because the exponent is 1. When we break it down, we get 3x squared plus 5x minus 2. 3x squared plus 5x minus 2 is a quadratic factor. Okay. Something to know is that every p of x that you start with can be broken down to a combination of all linear factors and quadratic factors. Okay. The hope is that when we get these, that we understand then how can we break those quadratic factors down even further. Okay. And at that stage, we're going to then rely on our Algebra 2 skills, Algebra 1 skills, that kind of stuff. That's a good question. That's kind of the nuts and bolts of everything we've done in the last 2 or 3 days. Okay. If you can do that, I think you've got a pretty good understanding of the things that we've gone over, the things I've taught, and you'll probably be pretty successful in tests and quizzes with that stuff. Okay. Something to remember, these are just options, right? These do not, when you write this list of P over Q, that does not say that every single one of those zeros that you end up finding are going to be from this list. What this list says is that every rational zero that you find, every single rational zero that you find will be in that list. Okay? When we've talked about how we can have irrational solutions, we can have imaginary solutions or zeros, and they don't show up in that P over Q list. Okay? Any others? Nothing else? Sure? We got time. So what they're asking for here is for you to find all the real zeros of P. So they're saying go ahead and go through that Same process you just went through with P over Q's. So there's our p-value, or I guess it's our a sub 0 that's eventually going to give our p-values of plus or minus 1, plus or minus 2, plus or minus 4, and then plus or minus 8. We look at our a sub n term, which is just a 1. So the q value then is plus or minus 1. So our p over q's are the same as that list right there, right? As we go through this, you're going to obviously have to check all these. It might be a good idea to use a graph, but I think kind of the mindset of the author of this question was to go through the synthetic division, find your zeros, and then see what those zeros tell you about this polynomial. Okay, so let's do this. And we might cheat a little bit because we already know what these zeros are, but then we'll talk about how we can use that to develop a graph. Okay, so again, like if I started with blindly starting at 1, bring my 1 down, 1, negative 4, negative 4, gives me 2, 2, so 6, and then 6, and that gives me a remainder of negative 2, right? So again, I'm looking for, when this is a positive number, I'm looking for a quotient that has all positive numbers down here. That didn't happen, so it doesn't tell me anything about the other numbers. 1 is not an upper bound or lower bound, so the only thing we can do is cancel out 1. Okay, so 1 does not work, and now we're going to try negative 1. So plug negative 1 in. I'll bring my 1 down, multiply, gives me negative 6. Multiply gives me 6. 12 then, negative 12, negative 8, positive 8, and that gives me 0. Okay. Now what most people would probably do, so you know that negative 1 is a 0, so x minus that is a factor. Okay. And then we go to the next one. We go to the next option here, and choose the next option. Basically, looking at this, right now, I guess if we see this, we could say we used a negative number, right? And this is positive, negative, positive, negative. Let's use this as being positive. We can use zeros however we want to. So does that alternate? So what's that tell you about negative 1? It's the lower bound. So I know I don't have to choose and look at any of the other negative values because they're not going to work. Okay? So that negative's gone, that negative's gone, that negative's gone. And I cut my now potential list down quite a bit, right? Okay? Now I don't know necessarily whether the negative 1 is going to be a double root or not. So I would try that again just to save time. I'm not going to do it because I know it's not going to be a double root. Does that make sense? But then I go to the next one. I go to 2. And now I'm going to bring my 1 down, multiply by 2. Add straight down. Gives me negative 8. Add straight down. And then gives me positive 8. And that gives me a 0, right? So now I know x minus 2 is a factor. Okay, because I get that 0 there. Now I would just be kind of intelligent here. Think about what we started with. This was x to the 4th. This now went to x to the 3rd, and now this became x squared, right? Well, when your leading coefficient for your quadratic factor, x squared, is a 1, you have much easier techniques to use than synthetic division, right? I would not use negative 2 again. It does work, or sorry, positive 2. It does work here, but ultimately, when you're getting down to that quadratic and other questions, a lot of times it probably won't work again. Okay. So then you got to go through your other lists and everything. Once you get down to something squared, though synthetic division can keep you going, my suggestion is just to take that x squared minus 4x plus 4, and you know that thing will factor to x minus 2, x minus 2, right? So that's what that thing there factors to. You've already got these other factors of x plus 1 and x minus 2. So to bring those down. So that's my p of x, right? if I look at this information, if I look at that stuff right there, I've got my zeros. My zeros are at -1 and +2, right? Zeros at -1 and +2. I've got my original polynomial x to the 4th. Okay, I'm going to graph a quick sketch here, and this is one of the reasons why we're doing all this stuff in chapter 3. If you remember x to the 4th, we talked at one point earlier in this chapter about end behavior, right? Well, x to the 4th, that's a +1 out in front, so my end behavior is going to do something like this, correct? Okay. Now I've got zeros of -1, okay, and I've also got zeros of +2, right? All right, but that's a multiplicity of 3, right? So that should tell me kind of the behavior that's happening at +2. I'm passing through at +2, right? A multiplicity of 3 at +2 is going to kind of look something like that. Okay. I have an odd multiplicity at -1, so I'm passing through. That's going to kind of look at -1. It's going to kind of look linear, passing through there. If I can get to pass through there, something like that. Okay. Now we also know some other stuff. Looking at this, my y-intercept's -8, isn't it? Okay, so come down here to, maybe -8's down here somewhere. I know I'm going to pass through there. Now I don't know if I reach my maximum or minimum before -8 or after -8, so I don't know if the minimum is over here. Just going to do something maybe like that. Okay. And we now have kind of a rough sketch of what our function should look like. We could use some test points if we wanted to. Choose x to be 1, plug that in, and see what you get for your y value, and then you plot that point. But that's kind of the general shape of our graph. So I'm going to go back to WebAssign and say, okay, which one of those looks like that? Okay. This one kind of looks that way, right? But it's flipped, isn't it? Okay, so isn't this the one we want? We got a y-intercept of -8. We got that cubic-looking shape happening here at that intercept because we had a multiplicity of 3 there. Here you got that linear kind of shape because you got a multiplicity of 1. So that's the choice that you want to make. Does that kind of make sense? Okay. And the hope is that, after, I'm not saying it's going to happen this year. Hopefully it does. But it might be another year of math under your belt. It might be 2 years of math under your belt after this. But eventually you're going to be able to look at those x's of 4th and not have maybe exactly the picture in your mind, but you've got an idea of what it looks like in your mind. Okay. Every time you see x squared, you know roughly what it's going to look like, right? So the hope is that eventually x cubed, x to the 4th, x to the 5th, you have rough images in your mind of what they look like or potentially what they could look like. Okay. Again, another good question, and if you can do that, then those two last questions kind of sum up everything we've done in at least sections like 3.3 and 3.4. Okay. Let's stop there. I got a question for you that I want you to answer. So stop.